All right, we're going to talk about how to make a line graph today. Best thing you could do right now is get organized. You should have page 5 of your graphing packet, and it's a line graph that you're going to make, and you should also have a piece of graph paper right beside that. The other handout that would be useful to have is I gave you a handout on how to make data tables and how to make graphs. It's a two-sided piece of cardstock. You might want to be on the side that talks about how to make graphs. I'm not going to go stepwise through that handout, but what I am going to do is sort of use the ideas in that handout to show you how to make a graph. So if you, all right, well, this is page 5 of your packet. It will have a handout that looks just like this. It says Practice Makes Perfect Line Graphs. Your handout's a little longer further down than mine. I cut this off so I could work on the screen. You also need a piece of graph paper.
Tiana James, please come to the office. Tiana James, to the office.
So here's your graph paper right here, and you're going to use that graph paper to graph this information right here. So the first thing we got to decide is what kind of graph are we going to make. And to do that, you look at this variable, the manipulated variable, and if it's a scale of numbers, you make a line graph. If this is a type of something, you'd make another kind of graph we'll learn later called a statistical analysis graph. Well, this is a scale of numbers, so we're going to make a line graph today. So I move this around a little, and now what we're going to do is down here is where you put your manipulated variable. In this case, it's temperature, so we're going to write temperature across the screen. And the units are degrees Celsius. And then let's come up with a scale that's going to work on ours. And the best scale that we're probably going to use is probably just counting by 5s, it looks like. So I'm going to go ahead and put a scale on here. I think I can start at 0. And then let's see if I go, let's try it, see if it works first. If I go 5, 10, 15, 20, 25, 30, 35, 40, takes up more than half of the graph, which is what you need to do. And so that would work. If it didn't take up more than half, you'd have to spread that scale out further. So we're going to go ahead and fill that in. So this is going to be a 10, and then 15, 20, 25, 30, 35, and 40. And you could go all the way across, which if making a real graph, you probably would do that. So now we need to come up with our y-axis. And our y-axis, we're going to look at our responding variable for that. And our responding variable is speed. And these are the speeds that we got. So let's go ahead and label our y-axis. So the y-axis is going to be labeled speed. And the units are kilometers per hour. And I think the best units for, or the best numbers for speed, we have to graph between 105 and 117 right here. And so we'll have to come up with a range. I'd say probably between 104 and 118 would work perfect. So we need a scale that would work for that. So just looking at that, I think counting by 1 starting at 104 would work. So 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, and 118. Okay, and the scale that we would be using to figure out what each little tick mark is counting by, I like to divide by 10. So I take a difference, for example, between 116 and 118 is a difference of 2 divided by 10 tick marks. So I'm counting by 0.2s on this scale. And on the other scale, I am counting by, it looks like, a difference of 5 divided by 10 tick marks. Is that right? We're counting by halves, it looks like. Okay, I actually just caught a mistake. I had a 0 here and realized that would not work. I can't start at 0, go to 10, and then change my scale to counting by 5s where I started counting by 10. So I switched this to a 5, 10, 15. Now the scale works. Now to figure out the little tick marks here, what is each little tick mark? I would take a difference of example between 5 and 15, which is a difference of 10 divided by 10 lines. I'm counting by 1. This could get a little tricky here, but basically these are going to be your x-axis points, and this is your y-axis. And so you're going to plot 5 and 117.2, 10 and 116.0, etc. I'm going to have to zoom in and out of my screen to do this, so I think I'm going to just go ahead and put the points on and then start the video again so you can see what I did. Okay, I went ahead and put the first data point on, and you can see I have it at the 117.2 right here. So I'm going to go ahead and put the rest on, and then you can do the same. Okay, I put my data points on. I just want to make a note. This data point right here actually was not at 30, it was at 31, so I had to start one tick mark over before I put that on. My data points aren't going to be as precise as yours just because I'm working from the screen here, which makes it really difficult, but that should give you a general outline of where your data points should be, so if you look at your paper compared to mine. Last thing we need to do, actually 2 more things. We need to add a title, and we need to add what's called a line of best fit, or a best fit line. We don't necessarily connect the dots. When we draw a line of best fit, we try to average the errors. So usually it's going to be either a straight line or a very smooth curved line. This data to me looks mostly straight, so I'm going to draw a straight line through the data, giving myself a best fit line there. So I'm going to do my best to draw my best fit line, and it might look something like this. Notice I try to take kind of an average. I have a data point below and a data point kind of above the line. You want to average those. The reason they're not all on the line is because of errors in a science experiment. So that's the reason for that. Okay, I accidentally erased my data points, and I'm not going to draw them all back on there, but you should have your best fit line now that averages that. The last thing we need to do is put a title up there, and your title should include your 2 variables. So your 2 variables were the temperature and the speed. So it's just like making a data table. It would be something like temperature versus speed. And so you could have a little more detail, like outside temperature versus speed of ski racers would probably be an even better title. So this was probably a little cumbersome, this video, getting used to the new technology, but hopefully it gives you an idea of how to graph.